Okay, for these notes, we're going to do the system of equations elimination method. You're still going to get three different types of answers, whether it's one solution, no solution, or infinitely many. So a one solution will always be an ordered pair, and that would be x comma y. No solution, we are used to graphing. No solution would be parallel lines. However, since we're not graphing, we'll have to figure it out a different way. And when you eliminate two equations, the x and the y go away, and you're left with a false statement. Now, false statement means like 0, comma 5. Oh, I'm sorry, not 0, comma 5, but 0 doesn't equal 5, or 4 does not equal 9. Those are not ordered pairs. It's just a statement. It just says 4 that can never be 9, or 0 can never be 5. So the opposite of false statement would be a true statement, and that's what would happen if you have infinitely many solutions. So the x and y would go away, and you are left with a true statement. Now, a true statement would look like 0 equals 0, or -4 equals -4, as long as the same number is on both sides. Now, for elimination to work, the equations must line up with the variables and constants above and below each other. So, for example, you would have 5x plus 4y equals 9, and then you would have the x's line up under there, the y's line up, and then the constants line up. That's the most familiar way. The most popular way is standard form, but you could technically have an equation where y equals 15x plus 6 lines up with negative 2x plus 9, because the y's are lined up, the x's are lined up, and the numbers are lined up. Now, the two problems that I see right away, or the one problem, is that none of them are opposites. So to get something to eliminate, to cancel out, we need opposites. Because think about it, when you're adding, if you add 5 plus -5, that cancels out, it becomes 0. That's what we need, but we need it to happen in an equation. So this flow map is going to help you in any elimination problem. Now, some of you may learn really quickly that you don't have to follow all these steps, but if you don't see it quickly, this flow map will never change, and you can always get the right answer if you use it. So whenever you're doing elimination, keep this page of notes out. Now, I'm going to flip to the other notes, but I'm going to use this as a reference. So whenever I speak about the flow map, I am referring to this flow map. Now, where the actual problems are, I actually started not on example 1, not on example 2, but I went to example 3 instead. So we have the variables lined up. We have the x's, we have the y's, and we have the numbers. So this is a perfect way of doing elimination. Now on the flow map that I just discussed, the first step, the first box says, multiply the first equation. So since I multiply, I'm going to wrap the first equation in parentheses, by the opposite first coefficient of the second equation. Since that coefficient's -2, I'm going to multiply by 2. So 2 times x is 2x. 2 times negative y is negative 2y. 2 times negative 2 is negative 4. Now, this equation and the one that I just created are actually the same thing. We are just manipulating, changing it to use it for what we want. Now, in the second step, it says multiply the second equation by the first coefficient of the first equation. So the first coefficient's 1. So I'm going to multiply by 1. You only want to change one of them. You only do the opposite of 1. So 1 times negative 2x is negative 2x. 1 times 2y is 2y. And then 1 times 2 is 2. The third step of that flow map is add equations. So now we have 2 equations that can eliminate. We can do that because we have opposites. 2x plus negative 2x is 0. The negative 2y plus 2y is another 0. The negative 4 plus 2 is negative 2. So this is saying 0 equals negative 2, which we know cannot happen. So it's a false statement. If you look back on that flow map that I just discussed, a false statement means that it's no solution. So you can write a sentence, no solution, because I got a false statement. Now in example 4, you're going to do this same flow map. Notice that we only did the first 3 steps. We're going to multiply the first equation by the opposite of the first coefficient of the second equation. So the opposite of negative 5 is 5. So I'm making that opposite. And then I'm going to distribute in. Most common mistake, students forget to distribute the 5 to the 6. Now the second equation, I'm going to multiply by the first coefficient of the first equation. Notice that I kept it the same. You only do the opposite of 1. Now the third step says we're going to add. Once again, our 10x and our negative 10x cancel out to become 0. The 40y plus negative 40y cancels out to become 0. The 30 plus negative 30 cancels out to become 0. So 0 equals 0. That's a true statement. Since we got a true statement, look on your flow map from the previous page, which says if you get a true statement, it's infinitely many solutions. Now, if you were to graph, you would get the same answer for this. Hopefully you remember that when you graph, you would get the same line. Now, what we're going to do is back to example one. One that we haven't done yet is one solution. Now, in example one, we have to teach you word problems anyway, so that's why I'm going to teach you it for the one solution as well. So it says Dr. Algebra pediatrician has 3 annual checkups and 3 sick visits scheduled next Tuesday, which will fill a total of 231 minutes. So we know that we're going to talk about a Tuesday schedule. We know there we have 3 checkups. We have 3 sick visits. And we know that it's going to equal a total of 231 minutes. So annotate, write yourself questions, come up with key facts. That's going to help you build your equation. Now, later in the word problem, it says next Wednesday, so we're going to make an equation about Wednesday. He has 2 checkups, 3 sick visits, and it's going to take a total of 174 minutes. So that is important parts. Now, with that, we're going to now come up with our unknown. Our unknown, instead of having one variable, we need to know the time for the checkups and time for the sick visits. And then time for the sick. Now, it does not matter which one you make your X or which one makes your Y. You just have to make sure that the right number goes with it. What I mean by that is for my Tuesday, there were 3 checkups, so that's my 3X, plus my 3 sick, which is my Y, equals a total of 231. Whereas my Wednesday equation, we have 2 checkups, which is my X, plus 3Y equals 174. Now, since we have the system of equations, you can do the method that we just learned. We multiply both equations. So the opposite of 2 is negative 2, and then we'll just bring down the 3. We only make one of them opposite. So negative 2 times 3 gets us negative 6. X minus 6y equals negative 462. Now 3 times 2 is 6x. 3 times 3y is 9y. And then 3 times 174 is 522. So now we're going to add these. We're going to get 3y equals negative 462 plus 522 gets us 60. We have a one-step equation. You're going to divide by 3. Y equals 20. Now, that's only half of our answer. We just found the time for the sick appointments. What you need to do now is plug it back in, which is our step 4. It says if you are left with an X equals a number, Y equals a number, then substitute that number in. It does not matter which equation you choose. I'm just going to choose the blue one because it was first. So instead of Y, I'm going to write 20. And then equals the 231. 3 times 20 is 60. Minus 60 on both sides. So then I have 231, take away 60, gets me 171. Now I have a one step. So now I have how much time is allotted for my checkup or for Dr. Algebra's checkup. So you can say there is 20 minutes for sick visits and 57 minutes for checkups. Now your turn 1 says a clothing store is donating socks to various charity. So the store gave 5 regular packs of socks, 4 value packs to a shelter, and it contained 289. So we're going to make a shelter equation. So we're going to have 5 regular, 4 value, total of 289. And then in our second equation, we're going to talk about foster care. So 6 regular packs of socks, 4 value packs, which had 318 total. And it equals 318. So we need to come up with what is our variables going to stand for. So since I saw regular socks first, I'm going to put that for my x, and then my y is value. And then I'm going to make a shelter equation. And then I'm going to make a foster care equation. So for my shelter, I had 5x plus the 4y equals the 289. And then for the foster care, I had 6x plus 4y equals a 318. And now you use the flow map just like you did. I'm going to make one of them opposite. And then you're going to just distribute. So my new yellow line will be down here, and then my new blue will be down here. So negative 6 times 5x is negative 30x. Negative 6 times 4 is negative 24y. 289 times negative 6 is negative 1,734. Now I'm going to do my blue equation, my foster care equation. 5 times 6x is just 30x. 5 times 4y is 20y. 318 times 5 is 1590. And now we're just going to add. Negative 30x plus 30x goes away. Negative 24 plus 24 is equal to negative 4y. And then negative 1734 plus 1590 equals negative 144. When you divide that, your y is going to be 36. Now, remember that's only part of our answer. We just found how many pairs of socks were in the value pack, which was 36. So now we need to find how many socks were in the regular pack. So it doesn't matter which equation you want. I just picked the first one. So 5x plus 4y equals the 289. You're going to plug that into the y value. So 4 times 36 gets us the 144. And now it's just a two-step. So 289 take away 144 is 145. Divide by 5. You're going to get x equals 29. So the ordered pair is 29, 36, but that's not anything in this problem. We need to explain what the 29 and the 36 mean. So if you go back to the unknown, you can say there are 29 pairs of socks in the regular pack and 36 pairs in the value pack. So we're going to basically do the same thing for example 2 now. But students tend to find this a little more difficult because we're talking about value of money, which sometimes leads to decimals. So let's be careful here. So the value of a penny is 0.01. The value of a nickel is 0.05. A dime is 0.10. A quarter is 0.25. Half dollar, 0.50. A dollar bill is just one. $5 bill is 5. So on and so forth. So this may seem silly, but moving forward, it's actually going to make a little bit more sense. So in example 2, it's still a word problem. It looks smaller, but we just got to be careful with the decimals. It says Stanley has $2 in dimes and quarters. So what I care about are quarters and dimes. If he has 11 coins total, how many of each kind of coin does he have? So we know that he has coins, and we know that we have a value. So we know that he has $2. So let's talk about the value. We know the value has $2. And we know that he has dimes. So I'm going to put the 0.10 because it's a dimes. And we care about the 0.25 because it says quarters. But now we know that he has dimes and quarters. But how many does he have? He has 11 total. So that's actually going to be our equal sign. So we don't know how many dimes he has. And we don't know how many quarters he has. So to make our equations, we have the coins and we have the value. So we know that he has dimes, which is x, and we know he has quarters, which is y, equals the total 11. We're just counting it up. So we don't know how many of each. Now the value, this is where it gets a little complicated. The value equation is how much is that dime worth? That dime is worth 0.10 x plus how much is that quarter worth? 0.25 equals how much dollars does he have? 2. So now we have the two equations. So we're going to multiply the first one by the opposite of 0.10 and the second one by 1. So then negative 0.10x minus 0.10y equals negative 1.1. Now, the nice thing about the blue equation, when you multiply by 1, nothing changes. Now, when you add it up, you have to be careful, especially with decimals. The x's go away. Negative 0.10 plus 0.25 is a positive 0.15. Negative 1.1 plus 2 is 0.90. So if you divide that by 0.15, you're going to get 6. Now, that is just how many quarters he had in his pocket. We need to find how many dimes he had. So I'm definitely going to pick the yellow equation because it's the easiest one. And instead of y, I'm going to put the 6. And now it's just a one step. So we just found out quite easily how many dimes he had in his pocket too. So you can say Stanley had 5 dimes and 6 quarters. Now, in your turn too, it's very similar, but instead of coins, it's actually just dollar bills. So you just want to make a money equation and a value equation. So it says Stanley has $180. 180 goes into the value because that's how much money of value he had. He had $5 bills and $10 bills. So that's also the same for money. So he has $5 bills. And then he had $10 bills. And he had 20 bills total. So we don't know how many $5 bills he has. And we don't know how many $10 bills he has. So what you want to do is do x plus y equals the 20 bills. And then we have 5x plus 10y equals $180. We're going to multiply the first equation by negative 5, second equation by 1. So then we have negative 5x minus 5y equals negative 100. The nice thing about multiplying by 1, nothing changes. So those go away. We're left with 5y equals 80. Divide by 5. You're going to get 80 divided by 5, which is 16. So we just found out that he has 16 $10 bills. So plug it into the easier equation. And then now we know he has 4 $5 bills. So Stanley has 4 $5 bills and 16 $10 bills.